Hello and welcome to the third Func Prog Sweden this year. First up, I would like to thank all recurring viewers. Thanks for coming back, and to all new viewers, welcome to Func Prog Sweden, the meetup and channel where we explore functional programming. So, over to the agenda of today. First, we'll have a short intro by me, Magnus, and then we'll have the presentation, Android Architecture Design with Koin by Arnaud. And after that presentation, we'll have the hobby scale, making web apps with minimal fuss by Martin. And then in the end, I'll go through the schedule and the summary of the meetup, and also announce the coming meetups. First, I would like to thank Odabeat, our video stream sponsor. Odabeat is a small but growing IT consultancy company based in Stockholm that also now have an office in Vietnam. Most people at Odabeat have a background in functional programming. If you want to know more about Odabeat, check them out in social media or on odabeat.com. If you want to support the channel or the meetup and the community, which you of course want to do, you head over to the meetup community and make sure to become a member. You subscribe to the channel. And if you really want to support the meetup group, then you can head over to the merchandise store at funcprogsweden.myspreadshop.net, where you can get a t-shirt like I have here, as you can see. Yes, and there are also more stuff if you want to. All the money goes straight back so we can make more meetups. If you have questions during the meetup or during the presentations, please ask them in the YouTube chat and we'll read them to the presenters so they can answer them. With that said, let's get started. First presentation, Arnaud. Welcome, Arnaud, to Func Prog Sweden.
Hi, Magnus.
Hello.
Hello. Happy to be here.
You're warm welcome. And we're super happy that we're finally having someone with Kotlin coming on and presenting for us. Thank you very much. Hit it away. The stage is yours.
Okay, thanks. Yeah, we talk about Kotlin language. It's really focused on Android architecture, but we see it's also, there's a part about multi-platform architecture for the mobile side then. But then let's go and for this Android architecture design with Koin. I'm Arnaud Giuliani. I'm the Koin project lead, the guy that created and is still working on these open source projects since 4 years now. I'm also a Google Dev expert in Kotlin, and you can also find me on Twitter, on this Twitter handle at Arnaud Giu if you want. But let's talk about Koin and architecture today. Koin is in the latest version is in 3.15. This is the latest stable that you can update. And the next version, and we will see some of the feature today, is the 3.2.0. And it is already in beta. You can already play with it and enjoy a new feature around that. But let's go. And first, before talking about any architecture and stuff around, I would like just to share about what is Koin with the explanation of the core concept. And finally, when I have to explain what is Koin, I just say, yeah, just use Koin. It's easy then. But no. Koin, what is Koin is a dependency injection framework. That means it's a framework to let you configure all your dependency in your Kotlin application, and then you will figure out how you want to inject things together. And then if we have class A and B, what we want to do, what we'll give you is Koin is giving you a DSL here at the module section, where finally you are describing your stuff directly with the Kotlin language. That means it's a DSL that is compiling directly in your code as you are declaring a regular variable or something. But then the idea of the Koin DSL is to let you write your dependency directly with the DSL, and here call your constructor with the DSL. That means that here I will have to say to Koin that finally class A will resolve in class B, and here there's a little mistake here. Class B is resolving the stuff. That's okay. We will say that's okay. And you will have some constructor injection with the DSL. And then everything is built by your container. And if you want to retrieve instance in your API, you will use the inject and get API to unlock this, either with the Koin component interface. That means if you have a pure Kotlin application stuff, then a pure Kotlin application, you will just use inject and get, either with Koin component, either with a library that is already giving you the extension like Koin Android. That means that if you want to retrieve this dependency class B somewhere else, then you will have to ask your component to retrieve it. Just tag your class with the interface Koin component to allow you to inject this. And then you just make an instance of this class and resolve it by hand. Here, finally, the idea is to bootstrap your dependency. That means that it's not created directly by Koin, but more retrieve by Koin. And then finally, we use the Koin API to retrieve dependency. Either in the DSL, you are building pieces of your software and everything is built up by Koin. Here we are making really, let's say, a locator pattern usage here. Finally, just one thing is keep your Koin configuration simple. Less code equals less bugs. It's a chat as Google, well-known Google engineer that has these quotes, and I like it because this is also the way that we have developed Koin, is that finally we want really simple things, simple DSL to express things, and finally we want you to write really less code as much as we can. But let's dive into real application samples to really understand what we are doing today. And those samples will be found at those URLs, and I believe we will put it also in the resources on the video. It's based on Android architecture blueprints that is a application sample made by Google dev experts from Android and Kotlin, trying to demo some framework and some patterns. And here we will demo all MVVM and MVP patterns with Koin. One thing to see here is that in terms of Gradle dependency, if you want to use it in Android, you just have one dependency to use, that is Koin Android in the version that you want. But since Koin 3.x, you see that Strict dependency has been merged back in the main package. That means that you just use Koin Android and then you will gain access to everything else. Let's talk about the sample. Then it's a to-do application. It's really not super nice to see application, but it's a simple one that just lets you add to do. That means simple text things to, it's a list of to do to your list. And finally, what you will have here is something that is classical for Android. That means you will have an activity, task activity that is showing a task fragment. You will have a task view model that is dealing with your activity fragment. Then your view model will try to retrieve data from the task repository. And the repository will deal with the data sources, either a remote one or a local one. And then in local way, we will use task database. in terms of component, we will see each component of this architecture, from the UI to the view model to all the other components of repository, data sources. We will see how they are written in this demo application, and we will see how we can configure it in Koin in just one line. Here, our first repository will help us access remote to-do data. It's here, it's an object. That means it's already something that is already in singleton for Kotlin. It's a class that already has one instance, but then we can just reference it in Koin. In this line, we say single of the given type we want, and we in the lambda expression after that, we can express the way we build the class here, and then we build task remote data source. We specify directly a type next to the single keyword, because we want clearly to indicate here that we want just one type to be bound here. Then we have these data sources. If we have a single data sources in our application that is dealing with databases and other stuff, we will have the same type, task data source, that will be used by our repository, but then we want to make the difference between them. Then we will give some label, remote DS and local DS, that is here, two different implementation of the same task data source interface. And then we have in the first line task remote data source, and in the second one task local data source. And you see that finally we fill the constructor here with the get function of Koin DSL that indicates that we will resolve task DAO and IO dispatcher if you look at the class definition. And finally, what we have done here is that we declare the both task data sources here, and we give a different name here. It's quite readable, and then everyone understand finally what we are doing here. Let's go to our task repository, and finally how we can say to Koin that in our default task repository class here, we want to resolve firstly the remote data sources, secondly the local data sources, and then resolve other dependency. Here is how we do. We use the get function with inside the name function to indicate that we are using the right label for each of the data source here. This is important because then it's the way that finally we put label on different types. You see that finally in Koin it's super easy to define a type in your system, a singleton here, single of this type, and then a function to define here. And then we came to a database. We have repository, we have data sources. If you remind, the local data sources is using a database. It's Room, the Room database from Google. And here, what we can do also in terms of singleton is that we can declare something that is calling an API. We don't need to use directly a class. We can use directly an expression, because here we are, thanks to the DSL, we can run any line of Kotlin. And then what we will do here is build an instance of the database and then resolve the database to extract the task DAO. That means that the database instance can offer a function that is giving us the instance of that task DAO, and then we can give this reference to the other components behind. Then we have all the local data sources, the remote data sources, the repository. What we need now is our view models layer. This is the logical part just before the UI. And finally, what we want to do here is declare a view model instance. This class is really special to Android. It's extending the view model class here, And here in Koin, we have a special keyword view model to declare a view model instance, because then this instance will be hooked up in the lifecycle and Android, and then Koin will create the instance, and then your Android system will handle this instance for you. And the same as the other definition, we are just calling our class here and putting the get function to resolve the dependency. Finally, we are getting into the UI side. We have built up all the data side, the repository side, the database side. We have a view model that is ready to be injected in our task activity and task fragment. And with the magic of Koin, just a delegate function that is by view model allow you to have a lazy resolution of your view model instance, task view model here. It will allow to inject everything as well as the save state handle that is a particular parameter from the lifecycle of Android. But then just keep in mind that finally the task fragment is not something that we can create directly by hand, and then it's called by the Android system, and then Koin can create it for you. Then we will use a property delegate here directly to retrieve our dependency. If we are in MVP architecture, that means that instead of a view model logic component, you have a presenter component that finally help you to deal another way of your logic. The way we are declaring it with a Koin will be just a factory. That means that we just create a new instance each time we are creating a task presenter. And what you can see here is that we are dealing with a real function. That means that each time the UI is triggering a new task presenter instance, then it will create a new one each time. Then it will follow your UI in a natural way. But also here, you can see that we have a parameter to pass to your function that is creating your task presenter. That means that we can pass arguments from the UI from the caller that is here, the UI, to your task presenter. Then you can have a reference in terms of contracts or other stuff for your presenter. That is quite interesting. And then just the factory keyword here. And finally, the regular keyword in Koin to inject things in a class that is having the Koin APIs is by inject. If you have just to keep in mind things is the Koin DSL, where you open a module section, declare things with single, factory, perhaps view model, and then once you have declared everything, you can inject in all your classes with the by inject expression. And by inject also can take a lambda to help you describe what you want to pass in terms of parameter. And then you have a parameters of here, a function that lets you give the reference of a parameter to inject in your graph and then inject into the final component here. Then finally, we have built up all our components from the data to the repository to the view model from presenter and UI. Then, yeah, we need to organize stuff around modules, layer, feature. Yeah, finally, what you can do is just organize yourself how you want. Yeah, Koin is here to give you really easy and comprehensive keys, but then it's up to you to organize yourself with module. That means that you just declare a module like a variable here, just a value here, and then you can combine all those modules together just with the plus operator on the module there. Up to you to split into layer, to feature, and organize yourself in the way you want to split and allow you to test in the way you want. If we want to push the interest of the Android architecture a bit further with the clean architecture, that means that we will clearly dive a bit more into this domain aspect with interactor, entity, use case stuff. How we can see here this application that is having just task activity, view model, repository, and all the data components is finally, we can introduce a use case or an interactor here in the between your view model and your repository. And this is how we can finally handle it with Koin, is that you still get your view model like we were doing, but we change the dependency with the get task use case here. And finally, our use case will be just a factory of the get task use case class here that is resolving also is task repository. That means that your view model is creating its instance, is held by the Android lifecycle, is asking Koin for a get task use case instance. And finally, everything will be held for the entire Android lifecycle in a natural way, because your view model will just ask for your use case instance one time. Then it's really easy to finally create ephemeral components behind your view model just with a factory keyword. Let's wrap up, because we have seen many concepts and components, and finally, it's important to have the big picture in mind. This is our application. We have declared things for the presentation layer. We have declared things as view model presenter with factory or view model keyword. Every things below is declared as a single instance. That means that this is singletons. Okay, then in Koin you just write single with the lambda expression of what you want to build here, then the task repository, local data source. And then we have built up everything. We have declared everything in Koin, from the factory to all the singletons. And then in the UI side, we just need to use the Koin API stuff. And if we introduce the use case component behind the view model, we can introduce them as factory. The advantage of having factory instance at this level also is to ensure that we won't handle any state for the duration inside Koin, and then when the view model or the presenter is dropped, then your use case will be dropped also. Then this is the big picture of how we can declare things in Koin and how things are working. Let's go a bit deeper and go with the Android scopes topic. It's already a bit scaring topic, because finally it's always a bit tedious. And yeah, so the first question is, yeah, what's a scope? Scope is finally, for dependency injection framework, you can see as a space where we are maintaining instances for a duration of time. That means that it's not a singleton where finally is your instance are held forever. It's not factory that are just creating one time and they dropped out. Then it's somewhere finally where you want to use things for a certain duration of time. And after this time, we want to be sure that we want to garbage collect everything. Then why do we need some scope, especially in some SDK like Android and other runtime? What we want to do is be sure we are dealing with the same group of instance for the same duration of time. And then in Android, how it's going, then we want to be sure that this duration of time is completely compatible with the Android component lifecycle. We don't want to make memory leaks around here. Then if we think back about how we are building things without scope, just in a natural way, that means that if we have our UI or our activity here, just a my activity class that is super simple. We are injecting a presenter that is just defined as a factory here. What we will have here is that finally where configuration change is destroying your activity, then you will drop also your presenter. That means that your activity is created, you have one instance of my presenter, your activity is dropped, then your presenter is dropped. Then it's following naturally the life cycle. But finally, if you want to inject in the same area, you will need to specify that finally we hold instance in the same scope around my activity for the duration of my activity time then. And if we add something here, we add an extra component, my adapter here, that is using the presenter instance. If we want to be sure that my presenter, the presenter instance injected in my activity is the same as my adapter, we will need to use a scope. Then instead of using a classical activity, we can use scope activity of Koin. And then what we can do is in Koin, we declare just a section called scope of the given type, and then we declare everything we want in terms of scoped instance, and then every cell will be kept for you in this scope instance. And then here, if we drop the activity, we also drop the scope, because finally the scope is dropped just after the destroy of the activity. It's not a view model. If a view model is a special component in Android that will survive to any death of your activity, and then with Koin you just declare it with a view model, and that's it. Finally, the same instance of view model will be held for the same after a new activity has been created. The new instance of my activity has been created. But one thing here is that finally, if we are using scope and view model, we may lead into a wrong life cycle. We will lead into a mixing life cycle. That means that we will have objects held in a scope, whereas the view model will be held in the Android life cycle system. Then it will hold your previous instance of my adapter and then provoke a leak here. What we can do instead, if we really want that finally you have to decide either you are using an activity or fragment scope, either you want something that is surviving configuration changes like view model, then you have to be sure that your scope is configured to survive to this activity's default lifecycle behavior. And what we can do here is use the activity retain scope API here that is helping us create a scope that will be held as the same life cycle as a view model, and then we will have everything in the same life cycle. Getting access to the scope API in your activity can be done in two ways. Either you are using scope activity and everything is created for you, you just write by inject. Either you don't want to inherit from the scope activity from Koin and want to keep your class hierarchy, and then you are working on, you can just use the Android scope component interface to let you define your scope. You will have to define your scope here. Then we can have an activity scope, activity retain scope, or other kind of scope. But then you will manually deal with your scope, and then after that, you can write by inject in your activity, and then it will refer automatically with the right scope. Don't forget that finally, also, yeah, as I was saying, you also have the activity retain scope, the way that finally help you persist your instance through activities death. After that, we can also need to access some scope in a manual way. That means that there is other use case of scope, like if you are making an application that is dealing with wallet or stuff, or need to keep, let's say, data across several screens, then scope can be a good tools for you to hold instance between screens. You can get access to the scope API manually with getcoin.createScope or getScope. Then you will create scope and retrieve your scope with the given ID that you want here. And then you will pass everything in manual. Be sure to be careful because you can lose everything if you are not dealing carefully with your scope. Be sure to test everything down. One last thing about scope is a special one is the navigation graph. That means that some view model may be scoped to your navigation route. That means that it will survive. This will be the same view model instance for your application. How you can work with that, just use the Koin100x navigation components, declare your view model with the view model keyword here. And when you are injecting in and you want your view model to be persisted as a navigation graph view model, use the Koin nav graph view model function here with the idea of your navigation graph. And then everything will be okay for you. Yeah, scopes. I believe it's a hard topic, as I was saying. Let's wrap up a bit. Then how do you define a scope in Koin is just a section, a dedicated section for the given type where everything you are declaring components that will be held for this duration of time. Here we want to declare things inside the scope of my activity. You can avoid to use scopes if you are just using factories. You can, but then you won't be able to refer the same instance around in your components. To deal with this scope in your activity, just use the scope activity class or Android scope component interface. And then also to get the scope API, just get the static access getCoin, and then you will access to create scope, get scope, and everything that will allow you to resolve your dependency inside your scope instance. And lastly, don't forget the Koin nav graph view model function that lets you get the instance of your navigation graph view model. Yeah, heavy topic I was saying. Let's go with some more recent topic. And the first one is Jetpack Compose. Koin is proposing first API to let you inject your dependency inside Android Compose application. The idea is just to let you access your dependency in a natural way from your composable function. What you need here is just the Koin100x Compose package from Gradle, and then you will be able to get instance or your composable into composable function with just get or by inject if you want a lazy expression here. And also what can be done here is that inside your composable function, we have default parameter in Kotlin. Then you can also specify get here to resolve by default a dependency, but also that means that this composable can be reused. And then if you want to enforce another value of your dependency here, the my service parameter, then you can. Then you are not forced to use a Koin. It's just a default value. By default, you will use Koin in your composable function, but then it opens the road for you to let you inject other value if you want in test. The same way, we are proposing a view model instance with get view model and by view model expression, classical way to describe the thing. And then in the same approach, you can also specify default parameter value inside a composable function. If you want, we begin to play with the Jetpack Compose samples here, and we have a forked version of this Android GitHub repository, and here's the Compose samples, and we have one that is demoing how we inject dependency inside the Compose application. But today is clearly the first usage, and we want to explore more use case, more way to declare things in a composable function, and this will come later this year, I believe. Let's talk about dependency injection in the multi-platform world. Kotlin is a language that was mainly focused on the JVM and Android community, but today, not today, but since a while now, KMM, the Kotlin multi-platform, mobile multi-platform side of Kotlin, offer tools to let you really develop Kotlin with the Kotlin language, but for multiple platform in the mobile. Either the big picture for KMM is you can describe your logic with Kotlin and then inject it in your iOS application and Android application. The big picture around that is that finally you can still use your native UI code and use your library that is shared in common Kotlin code, everything, presentation, business, data access, and then finally everything will be bound back to a native API for you. That is super interesting because finally you keep your native stack, your native UI code, and then you begin to work really with common shared library. I like to play with one of a well-known KMM sample application that is a people in space that is made by John O'Reilly. And you can find the repository here on the GitHubs of John O'Reilly on the O'Reilly/people in space. And what is this application? Is a mobile application and several other, because he made desktop, he made web application in the same Kotlin repository. But then you see that we have the same purpose of iOS and Android application that is locating people in the ISS space station. And then how is it going? Finally, in the same workspace, we will have Kotlin code in the common parts. We will have Android application. We will have iOS application. We can also have backend and web application. And how finally we are thinking about dependency injection. We begin to think about dependency injection in the common code. That means that finally we can design entirely our dependency injection in the common sources, and then we will be able to use those Kotlin Koin modules in the Android and the iOS application. How we can do that? Finally, we are describing a few common components like JSON serialization library instance, HTTP client, repository, remote access API, and a logger here. You can see several. Finally, we are declaring components that are purely Kotlin or KMM. And then, especially here for the HTTP part, we are using Ktor, and then we can configure Ktor for the multi-platform HTTP client part. Then finally, we can, as you see here, we are declaring everything in Kotlin and in a Koin module, as you see the function command module here. And then you will see that everything down that as I mentioned, is available to be injected in your application. And also we have a bit of part here is that as a Kotlin multi-platform side, there can have been some part that need to be explicitly written for each platform. And this is the case for SQLite configuration. That means that in this application, we are storing local database data. And what we will need to do is that we will need to declare a module, a dedicated Koin module for each of the instance. And you can declare everything in a common multi-platform module with Koin. But if you have native component, then you will need to declare it one by one. And this is how we have to do. This is the keyword expect that ask KMM to have a definition of something, and then you will have to give the implementation on each platform. And here is the extract on the IDE, where we see that finally platform modules is declined for common part, iOS part, GS, GVM, etc., etc. In Kotlin multi-platform, one of the main mechanism is having an expect function, expect contra, expecting things finally that has to be implemented in a native platform. And then you have expect keyword, and then you have also the actual keyword that lets you implement everything down. How we can do finally, we implement our module platform. We have in the common module expect fun platform module, and then in each implementation, we will have actual fun platform module, and then we will describe how we instance SQLDelite for the given platform. Here we have GVM. It's the iOS side of the implementation with the right SQL driver. Finally, we have everything in the common space. Everything is ready in the common shared library, and everything is declared in Koin dependency module. And you will just have to declare things in your Android application or your iOS application to access your dependency. And this is quite magical, because finally you see that in the Android side, we just declare a view model instance, just one line here. We just ask the view model to retrieve the right dependency, and then that's it. Koin and Kotlin will make all the magic for you. This is the big picture to keep in mind. You can declare everything in the shared common code, Kotlin code, and then you can gather all this common Kotlin code with Koin modules. Yeah, it's almost the time and the end of my presentation, but I would like to share some new features that arrived lately, those months. And firstly, we have improved the new Koin DSL in 3.2 because there were one major pain of the community is having to write get everywhere in the function to resolve manually everything. Just as a reminder, it's because finally Kotlin here is a pure DSL and give you function to express stuff. Then we don't use any introspection, reflection, any kind of mechanism. Finally, Kotlin DSL is just running your function that is building your instance here. And what we have here is a new DSL, what we call constructor DSL, that finally will help you have a keyword, here is single off, and target directly your constructor with function, your constructor. That means that with the double colon character here before your class, you just write single off your class, and we will fill everything for you directly. You don't have to write function, you don't have to write anything else. Then it's super interesting because finally it gets rid of some really annoying code for us. How is it going? Finally, if we get back to some of the example I show you just before, we have a task data sources here that has a name, and we want to fill the task local data source class here with the constructor with get and get function. And with the new DSL, what we write instead is single off double colon character task local data source. We open a new DSL, and then we can write named and bind. This is clearly more readable and clearly more maintainable, as finally your DSL won't break every time you will change your constructor, and it will clearly more easy to read. Also, with simple definition like the view model, you will have a view model, and directly you can use your constructor view model, and then that's it. You're done. And the same with definition that are using injected parameter, we will handle everything for you. And then here we are using factory of, and then your constructor class directly here. We are keeping the same semantic DSL. You just add off at the end of the keyword, and then you can have the form with the constructor DSL. And then it's super interesting to use because it's still a DSL. It's still not using any kind of reflection. It's still it's filling everything in your constructor that will require a get function. Yeah, then in mind, same DSL keyword with plus of constructor classes. You will have all your default parameter of your injected param here, and you have options that can be filled by Lambda, named and bind. I believe this is something that the community will enjoy, because when you have lots of configuration and you broke your one constructor, you change your constructor parameter, then you have to change your Koin configuration. Now you won't have to do it anymore. One another stuff that we introduced in Koin 3.2 is the modular key structure. Is that finally, instead of declaring each module one by one and having everything with the plus operator in between everything and having a list of modules, what we introduce is the concept of includes. Is that finally your module can include other modules. It may sound interesting because it may sound really a standard usage, but finally, until now, people in Koin didn't have the real need of including anything. But now we can allow a module to include other modules, and it will help us clearly flatten everything for you and optimize the performance for you, and be sure that we load everything one time for you. And then we are flattening a complete module graph for you, and then performance are better. And then you can reuse the same included module in other module to be sure that you are including the same stuff. Finally, if you write app module here, that is a Koin module you use includes, that is including other module. To start a Koin module, you will just have to start Koin with the app module, and then it will use the app module, the data module, and the UI module, and everything will be flattened down. That means that if you have another app module and you also includes data module, the same data module and UI module, we will have only one instance, and then we will organize everything for you and be sure that there will be no conflict. Another super interesting feature is finally the way that we are opening Koin to the way that we are declaring components inside. Finally, there is a thinking of we could go quicker in defining our components, and also we are limited by the possibility of DSL. That means that finally the limits of DSL is that you can't analyze things for the developers. We can't understand, if we don't want to use introspection for performance purpose, then we can't analyze things in the DSL. It's really super hard to really understand the types and everything for you. Then this is one of a demand of the Koin community, is finally to open Koin to annotation here. And finally, can it be the dark side of Koin? Because Koin has always been DSL based, and DSL is the DNA of Koin. Not sure, because finally what we want to do here is to add another way to declare things for Koin, that finally more people will be likely to use Koin, and we will use the complete compiler plugin capacity of Koin to help us get into everything for you. The real magic behind is KSP. It's the Google KSP project, where finally KSP, it's a project that helps you make Kotlin annotation at the Kotlin compilers level. That means that it's super fast. We can make really all the type analysis that we want, and then we can generate everything for you that we want. Quickly, I will show you how we would annotate everything with we will use annotation in the to-do application that we had together just before. Here you will use the Gradle dependency that can be used. You have to use Koin annotation and Koin KSP compiler with the KSP plugin. But I will give you the reference on the online startup project to help you start with KSP at the end of this presentation. Let's go back to our super shiny to-do application, and then let's go with defining everything in Koin. And instead of using DSL, what we will do is finally use annotation. And we will use the same semantic for people here, is that we want everything to be super easy and understandable quickly. That means that just tag your class with annotation, and then it will be registered in your Koin modules and application. Then here, you just use @single or data source. And finally, we have two data sources. Then if we want to make the difference between the two of them, we can add @named. It's giving a label on the application, on those classes. How we will do to declare the repository, we will use the @single on it. But then if we want to target clearly the right dependency, we just use the @named on the right parameter of your constructor. Be sure that here, when we tag your class, the class with @single or another keyword here, we are declaring the first constructor of your class here. We are detecting everything for you, and then we will generate Koin module DSL for you. Then super easy, because finally just write @single on the repository, @named in the label dependency, and that's it. In the view model, we just use the @Koin view model annotation, and then you're done. And finally, in the UI, things are not changing. Finally, we still use the by view model, and for task presenter here, we just use @factory, as we want this to be a factory instance. And if we want to mention that a parameter is an injected param, we will just use the @injected param annotation. And that's it. Finally, in our task fragment here, we will pass the right parameter, and everything will be done for you. Then we will want to use some modules. You can keep mixing both old DSL modules with this, but also we can declare this DSL side as a function, not as a function, as a class module instead of DSL directly. That means that we have class module to help you declare things inside function, that we annotate the class with @module. We annotate a function with @single, a function that will return the right instance of what we are creating here. That means that the parameter of your function, the argument of your function will be injected for you, and then you can build everything. And the same for the task DAO, we have in parameter here, the needed dependency, and then we can do the right thing. Then super simple in the same way that we have a class here, @module, to say this is a module, and @single on each function that will return a result of building a new instance here. Something that is super interesting here is that you can gather finally easily all your annotated components with the @component scan here. That means you will say we scan for all annotated component in the right package, and then we will gather all of these instances in this module. And finally, to start using this new class module, just create an instance of this class and then use the .module extension on it. This extension will be generated for you with KSP, and this is the only thing that is generated for you. That means that we can analyze everything, and finally we just write everything down for you, and then you are done. You don't need to do everything else. You can just play with the Koin API. You can mix DSL, everything down between DSL and class module, then up to you to use what you want here. And you can even use Koin without any module if you just want to use a default module here and just start directly with a simple application. It's super important for us to be clearly super fast at compilation time. That means that we are benchmarking our KSP compiler to be sure that for 1,000 components, it's really super small compilation time. And then for us, there is no pain to use this kind of this plugin in your project, because we try to give new solution against existing solution like Dagger that propose really stuff based on compilation and takes really lots and lots of time to compile. And then here we want to make the trade. We can analyze everything for you, but it has to be super fast. And then we don't need to generate lots of stuff, because finally, one annotation thing will be one line of declaration inside one module. Then it's super fast to generate, and then can be a super good tool for you on the super good tool. Also, one thing super interesting is that this generated code is Koin DSL. You can perfectly debug step by step inside this DSL module, and then that's it. Then yeah, that's it. It's Kotlin compiler plugin thanks to KSP. There is no we give to the community, really try to give tools for them. We try to give try to give the best that we can to help you declare things in Koin, either DSL if you want, or annotation, or you can mix if you want. Find everything about Koin annotation project in this on GitHub here on insertkoin.io/koin-annotations. First beta version has been launched. Then you can already play with Koin annotation, and then that's it. Finally, I'm getting at the end of my presentation. Next step with Koin. Just to give you a status of the current Koin version and how things are going. I know that lots of people and company are still in Koin 2.x. It's time to migrate, because it's a version that has started more than 2 years ago, and then you need to migrate because then we are beginning to clearly highlight support time for the community. Then please, if you are still in Koin 2.x, go with Koin 3.x to benefit from all the updates, all the critical patches, all the performance updates for you. And also, we need to be close to all the updates of your library, like Android library, like Kotlin language level, everything for you. Then be sure to update. Why we need to update? Because finally, we want to establish a clear roadmap in 2022. It's time to declare a real roadmap for Koin, and what we want to do is have a release cycle of 6 months for every minor version. Why? Because it allows us to have a really interesting time frame to give patches, to fix everything, and to follow in a really measured way all the updates of the community. Because Koin is injecting for Ktor, for Android, for Kotlin multi-platform, for Jetpack Compose, is using now key SP annotation processing. Then we are following lots of ecosystem. Then we need to be sure that we can update things in a really timely manner. And we want to master our versioning system. That means that we want, what has been done in the past is that some minor version and the fixed version has been mixed, then it could cause some problem. We really want here to have a good direction in our way to manage version, and then we will keep minor version up to date with fixed version behind to have fixed updates, and then we will just highlight all the features, the new minor feature with the minor version, etc., etc. We want to separate everything. Fixed version is just patch, minor version is deprecation and minor feature, and major version will bring you hard breakings. But then it's super easy to see if you can update easily or not in a Koin version. Then how it goes in terms of version in 2022, the active version is 3.1. The 3.1 version will be active for the community until Q1 and let's say start of Q2, because then we will start to run on Koin 3.2.x. Why? Because mainly we have important updates like Kotlin version. That means that Koin 3.1 is running Kotlin 1.5, and we can't run Kotlin 1.6 directly on the Koin version 3.1. Then we are running Koin 3.2 and following in September, in the end of the year, Koin 3.3 that will follow also the Kotlin ecosystem language lifecycle and the Android lifecycle also. Koin annotation will be stable. The target is Q2 of this year. And also what's really helped us really rethink about versioning and having active track, helping people to update, is that finally in terms of download volume, Koin was something downloaded between 5 million downloads in 2020, 9 million downloads in 2021, and now we have a good trend of 3 million downloads, at least 3 to 5 million downloads by month currently. Then currently the trends of download and usage of Koin is super impressive, and then there's more and more people using Koin, and then we need to be super strong in terms of versioning policy. But also, I'm also pleased to share with you about Codzilla, the company that is helping about Koin, making long-term support releases. That means that we will ensure extra time support for all the last active version for you. That means that instead of having just 6 months of active version, we will continue to work on version for extra 9 months on it. It's super important for people that are really making their business with Koin to be sure that finally Koin is supported for a long time. And also, sorry, having some consulting service to help you build the application around Koin and develop everything around Koin. Then to have some more information about Codzilla, you can find Codzilla on codzilla.io, also on Twitter, codzilla_io, and on LinkedIn. Then it's super important to have a real company to support Koin on the private side, and be sure that finally we keep the DNA of Koin as it. That means it's completely open source, sorry, and community driven. There's lots of people that still continue to contribute. You can find the documentation on insertcoin.io, the blog of the developers and Coin developers. And just a few URL for you. Documentation here, if you want to directly go to the reference documentation. If you want to start play with Coin, here is a URL to let you directly have a quick start sample application. And yeah, that's it for me. I believe we have seen lots of stuff today. It's time for coffee or beer. Depends on where you are. And that's it for me. Thank you.
Thank you very much, Arnaud. Very good presentation. I don't have any questions. I have a shout out, I guess, from one of your person that's downloaded it. Like, Koin is a delight. It has been a delight to use Koin.
Great.
Yes. However, I have some questions. How came you into Koin, and what's your take on it? When did you start using it and contributing?
Yeah, my story behind Koin is I've been starting using Kotlin since 2015, and in 2016, I've started to put Kotlin everywhere. But in 2016, everything was really lots around Java ecosystem. Then for me, it was painful to not use the Kotlin language paradigms that we had here. Just a simple DSL to declare things quickly. And then it was one idea one day, and I began to publish the idea on GitHub and talk about that. And more people came to share this, help improve this idea. And then since 2017, yeah, this is the story of Koin, that is a little framework that is growing and helping building application around the world.
Really interesting. I think a lot of people have the same story, except you were able to get it to out to the world, actually. Yes. Yes. Do you have any? I mean, do you have any known brands or companies that's using Koin at this point?
I don't know if I can talk about it, but I know in France there's some banks, there's some video streaming services, a big application that are using Koin in production. I was also working in UK, and in UK there are I seen many use of Koin also. Then and around the world there are lots of usage of Koin, and it's really in a very, very diverse category of application, mainly on Android, but step by step, I see that people are using KMM side, and we see many usage of multi-platform dependency injection with Koin. It's interesting to see this adoption increasing.
Yeah. Thank you very much. I don't see any more questions in the chat. Thank you very much for your presentation. It was really interesting. Thank you, Arnaud, again. Thanks.
Thanks, Magnus.
And with that, then we will go over to our next presenter. That's with me here in the studio. Welcome, Martin.
Hello.
Hello and welcome. And we'll head over to your presentation. Hobby scale, making web apps with minimal fuss.
Yep.
Stage is yours.
Thank you. I'm just going to stay on this title screen for a moment because this is a interactive presentation. So some of the slides you'll be able to interact with. So I just want to stay on this until everyone has a moment to either type in that URL or scan the QR code. Though if you're just viewing this on mobile, then I guess it's kind of hard to watch the presentation and interact. So don't worry if that's you. You're not missing out on too much. Okay, enough stalling. Next slide. Quick disclaimer, I'm going to be talking about a tool called Lambdarum. I don't have any financial ties with it, but I am good friends with the creator of it. Okay, a little about me. As a hobby, I make web apps. For example, here's a web app where you can fight over which color is the best. People have already figured out how to use it. That's good. Yeah, so you pick a color, and then everyone else sees that color, and they can be like, no, I disagree. And so they might pick their own color. And as you see down at the bottom here, there has been some disagreement, 8,000 disagreements. I'll just pick blue and we'll be on, nope, blue, let's just move on now. Here's another app that I've made. It's called Question and Answer. I created this because at work we would sometimes have like leadership would give a presentation. Afterwards they'd take questions and give answers. But the tool we used for that I did not like. So I made my own. So you should be able to, at the bottom on your screen, be able to write your own questions here and place them. Thank you. I actually presented this once, like I showed this off as a presentation, then I used the actual app as my question-taking device, but save your questions to the end. Don't use this. Here's another app I made. Same company. I was annoyed with another tool we used, which it was called Moment of the Month. It was basically like a culture building thing where just at the end of each month, we would start up this app and you could write what your favorite moment of the month was, and it would like build a big list of them and cycle through them. The version we were using originally sucked, so I made my own again. So you can, yeah, write your own favorite moments this month if you want to reveal that. What's mine? My favorite is, let's be a bit pandering. Speaking at Func Prog, Sweden. That's mine. And so in my version, it falls from the sky and lands there. And if lots of people write their favorite moments, then it builds up a nice tower. On to the next app. Sorry, no apps. More apps later. Yeah, 2 years ago, I would have not bothered making these apps. These are all conceptually pretty simple, but there's a lot of infrastructure work that's needed. And to be clear now, when I say web app, so you think of like a static web page, that's not what I would call a web app. Static web page is fixed content. The backend's only job is to just serve that content. It has no other functionality. So a web app then is, it has content that's interactive. It has a backend that can get messages from that front end live at runtime and send out new messages if needed. Yeah, so for the infrastructure work, if like this was my job, yeah, sure, I'll tolerate that. But in my free time, I'm doing things to relax or to have fun, and I don't have that much free time usually. So yeah, 2 years ago, no way, I would have not made these things. Getting more explicit, like what kind of infrastructure work is there in particular? This is kind of just an arbitrary list, but just to give you an idea of the kind of legwork that's needed. You need like a database. You need some way of having persistence on your back end. Using the first app I showed where you pick the best color. It's a really simple app. You need to keep track of what the last color someone picked was, and you also need to like keep some kind of ID on them. So if they switch the color multiple times, you don't count that multiple times for the little counter in the bottom right. So yeah, you need some kind of persistence for that. And then you need some way of reading and writing to that persistent storage. Like, are you going to use SQL or no SQL? There's probably other things I don't know of. How are you going to send data to and from your front end and back end? So like HTTP, WebSockets. How are you going to encode that data, decode that data? Are you going to use REST? There's lots of decisions to make. And like usually you'll set up some kind of tool like GraphQL, for example, to try to make this more easy, but there's still configuration you need to do. And then just your environment when you're developing this. You need hot reloading, presumably, because if you want to see your changes you made to the front end, hitting refresh every time is time consuming. And you need to run the back end locally to make sure that your front end is communicating with the back end the correct way. And also so you can quickly see if changes you made to the back end work. And then DevOps stuff, like deploying your database, deploying your front end, deploying your back end, those configuration scripts. You need to set those up somehow. You want to probably automate those configuration scripts with like CI. Every time you push code to GitHub, you want these deploys to occur. So that's even more configuration then. You need some kind of server hosting. Someone has to run the backend somewhere. More configuration. And then there's like the actual stuff, like the things you wanted to do in the first place, the domain specific logic. You got to write your front end, you got to write your back end. So about 2 years ago, I discovered a tool called Lambdarum. It's developed by a guy named Mario Rajic, and I would describe it as a opinionated platform for creating and hosting full stack web apps. The tool uses a programming language called Elm. For the most part, I don't think people have heard of this language, though this is Func Prog Sweden, so maybe more people than normal have heard of it. But the short of it is it's a language that's strictly a pure functional language. So whereas, like, for example, F# has a lot of escape hatches, so you can be, quote unquote, pragmatic when you need to, and then like do mutability when you need to, or do some kind of unmanaged side effect when you need to. Elm, in contrast, does not allow for that. It's much more strict. You think of like Haskell, but this is less academic in its culture, and it's more of a simple language. If we go back to our web app checklist now, but for Lambdara, all these blue boxes, the boxes that have been checked off, these are things now that just Lambdara does for you. So it's just an implementation detail. Set up the database. I don't know how it's done. Lambdara does it for me. The data persists when it's on the back end. How do I, write code to query and read from the database? My code automatically has access to that state. It's a variable I can reference in my backend code. How do I send data to and from? Again, implementation detail. All I need to do is call lambdara.send to backend, or lambdara.send to frontend with a ID saying who I'm sending it to. Hot reloading, and running the environment, the backend locally. All I need to do is download the Lambdara binary, which is like you just add it to your path, and then you can call it from the command line. And then it's just one command line call, and you have it running locally. Deploying, again, just one command line call, and then you have it deployed. And setting up server hosting goes along with this. It's just handled automatically when you deploy. So the only parts you need to do when you're using Lambdara is writing the backend code and the front end code. Unfortunately, Lambdara can't do this for you, because that's like you're defining what your app does. You'll need to hire a programmer if you want these to be checked off automatically. So a bit more concretely then, as I mentioned, Lambdara Live and Lambdara Deploy you see here. But the first step would be just Lambdara init. You need to find an empty folder. You run Lambdara init. That populates the folder with your initial modules, and it gives you a little like starter app. And then Lambdara Live, when you run that, it shows the starter app in your browser and runs the backend automatically, and handles, if a file changes, it does hot reloading and such. Step 3, that's the one you actually have to put in the legwork for. You actually have to write your app. By the way, I'm saying business logic here, but since it's for a hobby, I guess that's kind of a weird term. But yeah, just the code that's intrinsic to defining what your app does. But once you've written that code, then step 4 is, again, a easy step. You go to the Lambdara dashboard. It has like its own website. You press the create an app button, give it a name, and then you just, when you do Lambdara deploy, it will send code to this app you just created, and then it will be live. To give you a better idea of what this looks like, here's the backend code for the best color app. Again, the first app I showed where you could fight over which color is the best. This is the backend code for that, and it's so little code I can fit it in its entirety on this one slide. It's like 30 lines. Admittedly, color index, it's just an enum of the possible colors you can pick, so that's in a separate module. This is something Lambdara defines. So these are functions I can use. And types is just, because Elm is a statically typed language, you define a backend model and a front end model, and you define the types of data that can be sent from the backend to the front end, and from the front end to the back end. So this is just a module that defines some types, and it's not very large either. And so don't worry if you don't know Elm then. You don't need to understand exactly what this code's doing. What I'm just trying to sell on is that it's very simple. If you did decide to learn Elm, I think you could pick this up like within a week. And as I mentioned earlier, like Lambdarum send to front end. So what this is saying is that when we get an update from the front end, we have this message. That's the data the front end sent to us. And if it's a client connected message, then we don't change our model. We just leave that as. The model is our persistent data that I mentioned earlier that we can read without needing to write any database queries. But then when we do the client connected, we send back to the front end what the current color is and how many times the colors have changed. And if the color is changed, like someone presses what their favorite color is, then we increment the change count and we add that new change count to our model. And the last thing we do is broadcast this new data to everyone, because yeah, everyone wants to see what the new color is so that they can react. Up here in the top right, I have just, it's a screenshot of the entire directory for this best color app then. So it's very small. You might notice the absence of any configuration files because again, Lambdarum is just, it's very opinionated in how it set things up. So there's no need to define all these different configurations. You don't need to write any YAML or any JSON or any of that sort of stuff. No JS file that like loads in lots of NPM modules and does weird things. No, none of that's needed. You just write some Elm code, 5 modules in this case, and then Lambdarum deploy when you're satisfied. This evergreen thing here is a folder that's generated by Lambdarum. And what that does is if you decide to deploy again, so you've already deployed once and you have some kind of data already out in production, and you decide, oh, hang on, I want to change something here, or I want to add a feature, or I want to remove something, and now your backend model is different. So you had defined this one type earlier, this one data structure to be your backend, and now it's a new data structure. What this evergreen does is it's creating a snapshot of all your types in your application when you do a deploy. So if you make a new deploy, what it can generate for you is just a function that's like your migration script. It just, here's what the old type was, your old backend model, and this is what we need it to be. Just implement this function for us, programmer, and then we can handle the rest. And then once you do that, once you've written this function that converts from the old model to the new model, yeah, then you're done and you can deploy, and you don't need to drop the entire state of your application in order to have a new backend model. And also again, you don't need to worry about like, because typically if you're doing this in like a outside of Lambdarum, you're writing like an SQL migration script, or you're being just very careful not to do any breaking changes. Like as your app grows, you just have more and more fields that can be none, like some kind of nullable value to handle the fact that this data did not exist earlier. Lambdarum sidesteps all that, but just when you deploy, you give it a function that says, here's how we get the old data to the new state. Yeah, so I showed you some simple apps, but at least if you're like me, your little skeptic in your head is going off and going, well, that's great, but how many tools fall apart when they like reach some kind of real world use case, or they just work until they don't because, oh, by the way, you need to do this thing and don't do that thing. No, you can't do that, but the compiler can't warn you about it. So I don't think there's a way in a presentation I can easily like dispel those fears. I think the best approach is to just show you stuff I've made. And if you see the stuff I've made, you can hopefully believe that I would not spend my free time doing this if it only worked half the time and was frustrating the other half of the time. It didn't work well in a lot of cases. So let's see what the other more complicated use cases might be. So here's an app I've made called Ascii Collab. It's a website for drawing Ascii art. It's like a shared canvas. So for example, if I type hello Func Prog, Sweden. Then hopefully, assuming the presentation didn't break, you should see that on your own screen. Actually, there is a 8-second delay between me saying something and you seeing it, so okay, there you go. Yeah, someone's, yeah. Hello world, hello you. And so yeah, this is something I made, I think like 1.5 years ago. The first version of it, which looks almost the same as this version we have now, took like 2 weeks to make, again, in my free time as well. And since then, I've just been, me, friends, anonymous people on the internet have all just been drawing some really cool ASCII art, actually. I'm not going to discredit some people. They draw really good stuff. So here's a little ASCII town we've been making. And one thing we can do, I have a mode here where I can show who drew what. So you can see like all this yellow text here, it belongs to the same person. And if you're wondering, the green text is me. So everything that has the green color, I drew that. But yeah, there's lots of cool stuff here. The reason I made my own version, because there are lots of other websites that will do ASCII art drawing for you. Or yeah, that also basically lets you do ASCII art on a shared canvas. The reason I made my own is because these other websites lack the ability to like undo. They didn't have the ability to like box select and copy paste, that sort of thing. And one crucial one is these apps are always at the mercy of the user to not just obliterate everything with spam. So what I can do is I can click on a user and I can hide them, for example. So now all their changes are hidden for me specifically. But also when you hide changes, I get an email. Like I have an admin account. I'll get an email and I can go, oh yeah, that person's just being a jerk. Let me hide their changes for everyone. So that's what I felt was missing from other ASCII drawing websites. So I felt the need to make my own. And it's been a lot of fun. Again, because there's so little friction to making these websites. Yeah, it's actually fun. It's like a self-motivating cycle of like, I just made this thing and cool, now I can use this thing in my app. Oh, but what if I added this other thing? And like, yeah, it's a self-perpetuating cycle. And as a result, yeah, there's a lot of ASCII art here. Another thing is possible. There are some links in the code that actually get highlighted. So I can like click on this. There we go. Oops. That's actually the wrong link. Let me reset real quick. I created a poster. Let's see. Yeah, that one. I created a poster. Oh, dang it. Okay, it looks like the iframe has decided to not scale down the poster. This is a 3,000 pixel wide image. So you're seeing a little corner of it. Okay, oh well. I have a poster in my bedroom of a huge chunk of the ASCII art. It's cool. You just got to believe me on that. Also, I printed out a t-shirt, which I'm wearing now, that also has a bunch of ASCII art on it, if that shows up well in the presentation. What I should have put in the About Me slide at the beginning was I also like ASCII art, but you know that now. What else have I made? A friend of mine, this friend being Mario, so the same guy who made Lambdarum, he hosts a Elm online meetup every month or so. He was using MeetUp.com to host the site, or to host the group, which I don't know if I haven't been keeping up lately with it, but at least at some point, MeetUp.com started charging group hosts. Okay, I should see you shaking your head. Yeah, nodding. Yeah, charges you money to run your group, which sucks. Like, I mean, I can understand why they're doing it because of discoverability. Like, people aren't going to find your group if you're not hosting it on MeetUp.com. But in this case, Mario's group, people were discovering it because he would link it on Twitter and on Slack. And so there wasn't any real value to having it on MeetUp.com. MeetUp.com was just charging some amount of money every month for no good reason. So I decided to make my own. It's called Meet Down instead of Meet Up. And it's basically designed to be a slimmed down, free, importantly, version of MeetUp.com. I can just hit search here and we can see some of the groups that exist. most of these aren't active, but I have my own group for Ascii art, obviously, and Mario's group here then. So every month or so, host a Elm Online meetup, which you're welcome to join, by the way. Next app. This one is not interactive. So this whole, the title of this presentation is called Hobby Scale, but when there's a will, there's a way. I find ways to get this into my work as well. So I work at a startup called Relia. And so what we've been using Lambdara for is to create a web app for helping people find realtors if they're planning to sell their home. The reason this is just screenshots at the moment is because we haven't gone live with it yet. We're planning to do so in 2 weeks or so. So the timing wasn't quite right, but yeah, so this is something I've been working on at this startup then. And again, if you trust my opinion is I think it's working great, but I'm the one who introduced it, so of course I'd say that. But one thing I can say is we have a UI designer on our team. He's programmed a little bit, he's worked with CSS and HTML, and so he knows a little bit, but he's definitely not a programmer. But because Lambdara is so simple to set up, it's just, download the executable, the Lambdara executable, and then run Lambdara live. It was the hardest part was setting this up on his computer, was in setting up Git. But once we had that set up, he could easily start up the entire application. Like it's running the back end. Running the back end locally is almost identical to running it live in production. And then what he could do is just go into the Elm code, and while he's not a programmer, he can look at text and go, okay, that text should be this, or oh, I can change these numbers and it'll adjust the spacing somewhere, which is great for me because it means a lot of the typical, the UX designer comes to you and asks, hey, can you tweak the value there, add some spacing here, change the color there, or add this new color, all those things he can just do himself, which greatly cuts down on the amount of time it takes to do those things. He can experiment with changes without needing to go to Figma, make the change there, ask me to look at the change, implement the change. So it's much shorter, it's much lower latency between making a change, seeing it in production. And also it's good for him because he doesn't need to wait on me all the time when I'm like, I'm busy with fixing a bug or, something like that. He can do it himself. So it's great for the both of us. There are more things I've made that were too time consuming to add slides for, and I don't think I'd have time in this presentation if I had a slide for each one of them. But real quickly, so at 2020 New Year's Eve, I made a pretend credit sequence for a disaster movie that all my friends were part of. The disaster movie, being surviving COVID. And so the credits is just a sequence of pictures of friends, funny things they said, and towards the bottom some statistics of who wrote the most messages in our Discord server. Fun stuff like that. Another thing, we used to run this game called the Sheep Game, which the goal of the game is everyone gets a list of questions, and the goal is to answer the questions the same way you think everyone else will. So you get points based on how many people have the same answer as you. That's why it's called the Sheep Game. You're being a sheep. This game's fun, but it's annoying to do it by hand because there's lots of tallying at the end to figure out who wrote the same thing as who. So I made a web app for it in Lambdara. The Ascii Collab webpage I just showed earlier. One of my colleagues asked me, hey, someone in our team is sick. Can we make a get well soon card using Ascii Collab? Sure, just start a new instance of it. Lambdara deploy, but point it towards another website instead. And then again later, can we make a goodbye card for a colleague who's leaving? Sure, why not? The first one took 30 minutes to set up. That's because I had to remove a bunch of features that did not make sense in a get well soon card instance of Ascii Collab. And then the second one took 5 minutes because I already had the simplified version of Ascii Collab set up, and it was just Lambdara deploy and check that it's running. You might have guessed it already. This presentation is running in Lambdara. That's more of a gimmick. I'm not saying Lambdara is for making presentations, but I'm already having fun using Lambdara, so why not? And again, another presentation. Everyone who's you can go back later and click on the link here. I'm not going to open it now, but yeah, it's about Elm. Surprise. Also at work, and specifically my previous job, so not the startup now, but the previous company I was working at. We had an issue with we have our app, and it's used in several different markets which have their own languages. So we need market specific translations for each one of these for this app, which means then that we need to somehow get all of the translations out of our code to a translator. So typically, you put them in a spreadsheet, give the spreadsheet to the translator. Translator will give you back the spreadsheet with another column filled with the translations. And then you, by hand, need to take all those translations and put them in the right places. So the solution I came up with was, well, why not make a app that looks at our source code? We'll have like a specific structure for translations, so they can detect this specific code and automatically create a UI that shows like the English text and then a blank spot for the missing translated text. And so then we can just point a translator to this web app, and they just can fill it in there, and then it automatically generates a pull request for them. So we don't need to do all this busy work in between. Another thing, a Discord bot. So this is also like stretching the use case of Lambdara, because a Discord bot doesn't need a front end; it's just a back end. The one I made does have a front end because I just use it for an admin panel, but it didn't really need an admin panel, but it was nice to have. But yeah, it's just basically running the back end. But the reason I still use Lambdara anyway was just because just running Lambdara deploy and I'm done is just so much faster than anything else. So who cares if Lambdara is like being an overachiever and also can offer me a front end in this particular case. Likewise for GitHub, I've written a bot called Elm Review Bot, and what it does is there's a tool called Elm Review that lets you. It basically does static analysis on your project. And so I'm using Elm Review. I'm running a few particular static analysis passes on all of the Elm packages, like libraries out there, and detecting common mistakes so that it can then generate a pull request on those packages with fixes to those mistakes. Yeah, so I've made lots of stuff in the past 2 years with Lambdara. I've really enjoyed making all these things. But this is not a silver bullet, so I want to have a trade-off slide here. For as much as I love Lambdara, there are drawbacks, there are limitations. So let's go over those, because I think it's interesting to see both where something excels, but what it gives away in order to do those things well. So the first one, Elm only. This isn't an accident. Like you might be thinking, what's Elm? Why Elm? The answer is that Elm is a fairly simple language. It's only pure functions, managed side effects. These things are really important, actually, for Lambdara, for it to work well. I guess in theory, you could make some kind of Lambdara tool in another language, and they probably already exist. But what I think makes it work really well what makes it work really well in Elm is that because Elm is just pure functions, for example, when you're writing a migration script, so it takes the old model, converts to the new model, it'd be weird if your migration function could suddenly run side effectful code to do something right in the middle of that. That could really mess up the migration. And so because you can't do that unless there's a type signature at the top of functions that says like if it can do a side effectful thing or not. And so because the migration function doesn't have that type signature, you can't do it. And yeah, so this sort of restriction then makes it much easier from Lambdara to do its thing and do it well. You don't need to like tell the users, oh, by the way, make sure not to do this thing or you're going to break your app in production. Another trade-off, so the CPU and memory resources for a Lambdara app are restricted. The reason for this is that when you write your backend, the backend code, it gets transpiled to JavaScript and runs in a Node instance. And so Node is typically single-threaded, and so you're stuck on a single thread when you're running an app. That might sound horrifying. And again, I call this hobby scale. It's not web scale because, yeah, don't use this if you're from Google. But there's a lot of applications out there where you don't need that much CPU power. All the things I've shown so far work fine with a single thread. Likewise with memory sources, they just work fine with a single thread. There's just not that many people hitting a web page made by an enthusiast in their free time. But even in the extreme cases, so for example, the Ascii Collab website, I linked it on Hacker News. So, it's like Reddit, but for programmers. And within a 1 or 2 hour span, it was just, the website was being absolutely bombarded with people. It was being bombarded with people spamming, copy pasting stuff that I won't mention here. But even despite all that, it was only like a couple spikes where the web page started slowing down, or like the backend started slowing down. It couldn't handle all the traffic, but otherwise it ran fine. I think a big part of that is, despite being more restricted in its resources, because Lambdara can choose exactly how, for example, it handles encoding and decoding data, because it can define that itself, it's just an implementation detail, it can do so in a very efficient way. So it's sending binary data to the front end, binary data to the back end. It doesn't need to generate a giant blob of JSON, for example. So the bandwidth is much less, even if your resources are also smaller. So yeah, there's trade-offs there. And of course, for example, the Really app, in that case, the reduced memory resources is an issue. So what we've chosen to do is, for example, we have a database with a large list of realtors, because we need to show the realtors on our the map we're displaying. So that large list of realtors, that's in an external database. We have control over that. We can choose how we want to represent that database. This comes at the cost then that because Lambda doesn't know about this database, it can't do migrations for it. It can't automatically encode and decode communication to the database. We have to do that ourselves. But it's an escape hatch where we pay a cost in the form of developer time. And the last trade-off then is vendor lock-in. So Lambdara is basically like vertically integrated, everything from development to deployment and hosting. And that's a big reason why it can work so well then, is because it doesn't need to worry about like, oh, but what if they use this database, or what if they use this type of way of deploying things, or this build script? Like, what if they want to use this, if we were allowing any language, what if they wanted to use TypeScript instead of JavaScript or something else, and with different, Webpack or Parcel? If all these options were available, then there's just no way Lambdara could be a particularly stable product, because there's just too many things to handle. Often these come at come in conflict with each other. That one build tool does not work well with another language, and so forth. So vendor lock-in means that Lambdara can work, can work very well within its contained universe, we'll call it. But vendor lock-in is still lock-in. So if Mario becomes evil one day and decides, nope, no more Lambdara for anyone, that sucks. Fortunately, though, there is a enterprise tier. So if you pay more money than usual, then you can have enterprise tier, which lets you have self-hosting. But again, if you're doing hobby stuff, this is probably less of a concern. And there's fortunately a hobby tier, which is free. So yeah, so if you're a business, then this stuff might concern you more than if you're a hobbyist. And in that case, you have another escape hatch in the form of paying more money. You get self-hosting. Yeah, so that's about it for my presentation. In conclusion, Lambdara is cool, but it's not suitable for everything. Let me stress that. I forgot to mention, actually, Lambdara has actually an anti-marketing page where it specifically goes through a list of why you should not use this product on the actual Lambdara website, which I think is really cool. I think it's good not to, oversell something and then just generate bad press because people misunderstand what this is for. But yeah, if you can use it, I recommend it. I mean, if you don't want to learn Elm, then fair enough. I guess it's not for you then. But if you want to learn Elm, or if you already know Elm, then yeah, I think you should definitely try this out. It's a huge time saver compared with, at least in my experience, needing to set up all the normal infrastructure work that goes into creating an app before actually writing the core business logic. Here are links if you want to explore any of the apps I made. These are all open source. I don't have links to everything. Like, for example, the credit sequence I made, that has a lot of personal information about my friends in it, so I'm not linking that. But most of the stuff is here. Yeah, that's all. Thank you very much.
Thank you very much, Martin.
Thank you.
Very interesting presentation. Very fun presentation also. I tried to select color, but people had other ideas.
I
should
told
really
my
have
sister to participate, and I'm certain she was bombarding purple. So
then I know.
there you go.
First question: How do you make Ascii t-shirts? Is that self, or there's a site or something? People asking, saying amazing t-shirts. So where do you make them?
I unfortunately don't remember. Maybe I remember. The site might be called Vistaprints.
Okay.
But if that's totally wrong, keep that in mind. Basically, it's a site that lets you print on the entire surface of the t-shirts, like the prints even on my shoulder, and it's on the back of my shirt.
Cool.
But yes, all I did was I took parts of the like stuff that I'd drawn on the Ascii Collab website, and I just put them together in a large, large image, and I sent that image to this website, and then they sent me back a t-shirt. And it costed me like $40, $60. It was kind of expensive, but I'm really happy with it. So
yeah. It looks really cool.
Thank you.
Yeah, you're welcome. Second, there are probably people out there thinking, I like this Ascii website, and he had like drawn like little things. You should start selling like off lots on your Ascii art. It's a good business idea, people.
Foolishly, it's an infinite canvas. So
oh my God! Don't tell it. Like, don't tell it.
I think it dilutes the property value. You should have told me this a year and a half ago.
Okay. Yes. Then how come you got into Elm? What was the reason behind?
The thing that really spurred it on, because I'd already heard about Elm before, but it was like just in the back of my head, never really wanted, or like never really got around to using it. But what spurred it on then was that at one of my past jobs, I was told at one point that I had the opportunity to help set up a website. We needed some kind of web app for something. I don't remember the details. But yeah, so this was a new website, greenfield project. I could pick the language. And so the first thing spinning through my head was not JavaScript, not JavaScript, not JavaScript. And so I thought, well, what else is there? And so then, because I already had learned, or not learned, but heard about Elm, so I figured, well, this is worth checking out. So I looked into it, and from there it just took off. It was like a language that really fit with what I was interested in, being simple, a pure language. People watching here hopefully know the advantages with functional style to programming. So
we hope so.
I don't need to repeat all that there, but language, the Elm language fit well with what I wanted to do. Yeah.
And then you're going live with the current site,
Realia.
Yep. In 2 weeks.
Yeah. So maybe we don't run into some issue along the way.
Yes.
But yeah, that's the plan.
Cool. So if you're selling apartments in Stockholm, that's the people that you want to target.
We're starting in Gothenburg.
Oh, you're starting in Gothenburg, actually. Yeah.
I'm not the business guy, but we've decided.
Stockholm is better, we know. Joking.
Apparently the housing market's better there.
Oh, it is.
That's what my boss has told me. Or maybe I've misheard, and that's not what he said at all. But
I'm joking.
That's where we're starting.
Yeah, they probably know more. Yeah. Yes, we also got a feedback here. Like, I've been meaning to do some more Elm as Haskell fan. This looks great. This looks like a great getaway to do so. Thanks for the presentation.
You're welcome.
Shout out. Yeah, thank you very much. With that said, thank you, Martin.
Thank you.
Yes, then we are at the end of today's schedule. So the next meetup will be the 4th meetup of this year, will be in 21st of April this year. And then we will be at the Volvo Cars showroom in Kungsträdgården. So if you're in Stockholm, or if you want to get to Stockholm, 21st of April, 18th set will be at Kungsträdgården at the Volvo Cars showroom. And as always, we will have 2 presentations, and of course, we will also live stream this. So welcome both on the stream and to come in real life. With that said, I want to thank again both presenters and all the viewers. Thank you very much, and have a pleasant evening. Bye.